5. Problem 67 reads forces during chin-ups. When you do a chin-up, you raise your chin just over the chinning bar, supporting yourself with only your arms. Typically, the body below the arms is raised about 30 centimeters in a time of 1 second, starting from rest. Assuming the entire body of a 680 Newton person doing chin-ups is raised 30 centimeters, and that half of 1 second is spent accelerating upward and the other half accelerating downward, so that you stop at the end uniformly in both cases. So draw a free body diagram of the person's body. I didn't do that, and use it to find the force of the arms resting because I don't know how I'm doing accelerating. So let me draw my free body diagram because I didn't do it. You got your person here. They got their force, and they got the force of gravity, and their force is accelerating them up. So F net equals ma. So big force minus force times gravity, or the force of gravity, equals mass times acceleration. Well, force of gravity, that's his weight, which is 680. His mass is going to be 680 over g, because mass times the acceleration of gravity equals your weight. So weight divided by gravity equals your mass. So force is going to be equal to 680 times a divided by g minus or plus 680. This is where we got 680. We need a, but we got kinematics for that. So v naught v 80 t, v naught, our initial velocity is 0, final velocity doesn't matter. Remember, we're only doing half of the thing, so our displacement is only going to be 0.15 meters because the other half of the way up, he's not pulling, they're just letting gravity pull them down, but they're still moving up, when you're doing the jump. And the time is again going to be half of a second. So we're just going to leave a as a for right now and solve for it. So d equals v naught t plus half at squared. Do some algebra. Our v naught's 0, so that'll kill that off. So 2d over t squared is going to be our acceleration. Throw that back into this acceleration. So force equals 680 times 2 times d divided by t squared times g, all plus 680. Throwing our numbers all right there. Throw that into a calculator, and the force the chin-up person is pulling up is with 763.18 newtons.